In example 5, part B, we could work this problem the exact same way that we did part A. We could sketch the line negative x plus 4, look at the area bounded between the x-axis and the line between the limits of negative 1 and 3, but now might be a good time to explore using the properties of definite integrals to help us simplify. So what I want to do is to rewrite this as the definite integral from negative 1 to 3 of 4 dx minus the definite integral from negative 1 to 3 of x dx. And so the left-hand side is going to evaluate as the product of 4 and the difference between my upper and lower limits. All I need to graph on my calculator now is the linear equation y equals x. And I'm going to do that between negative 1 and 3 on the x-axis. And if you substitute those values into y equals x, they correspond to a minimum y value of negative 1 and positive 3 on the y-axis. So let's take a look at what that graph looks like. And so here we have our graph of y equals x. The window settings are x min, negative 1, x max, positive 3, y min, negative 1, y max, positive 3, and the scale is just simply 1. Now you can see what's going on here. We've got, on the one hand, a positive triangular area, and on the other hand, a negative triangular area. Positive because we are above the x-axis, and negative because we are below the x-axis. So this area is going to be 1/2 the base of 3 times the height of 3 is equal to 9/2. This area is going to be a negative 1/2 times 1 times 1. So now we can calculate the value of our integral. So the left integral, negative 1 to 3, 4 dx, is going to be 4 times 3 minus a negative 1, that's the same as plus 1, minus the value of this integral. And I'm going to open brackets, because this includes a difference itself. So this was 9/2 minus 1/2. So 3 plus 1 is 4 times 4 is 16. 9/2 minus 1/2 is 8/2. 8/2 is 4, so minus 4. And that gives us a final answer of 12.